Okay, let's start then. Hi, everyone. This is the first in a series of talks we're going to be doing this week. We're calling it Tech for Dummies and Entrepreneurs. The aim of the series is to give you people enough context so that you can come up with new business ideas around tech, so that you have enough context to know what is possible, what's not possible, what you can build, what the technical difficulties are going to be, and all that. So the first topic we're going to be touching is today we're going to be talking about software engineering and prototyping. So we're going to talk about the different kinds of frameworks that are there. We're going to talk about how you can make your app without writing any code, how you can prototype your app, just see how it looks, how it works, and stuff like that. So yeah, let's begin. Can you see the slides?
Yes.
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 Cool. Just a notice, during the talk, I won't be able to see any chat uh, questions that you post. So if you have questions, just wait till I ask for questions. And if you have any, you can then tell me, like in between. So yeah, let's move on. Again, before we start, about me, I've been programming for like 2 years now. I'm in my third year right now. I have some work experience building software for startups, so some internship experience, etc., etc. I write software mostly for backend networks and distributed systems, and sometimes I also write front end with React. So after this talk, if you want to reach out to me, if you have any questions, any queries, anything at all, you can text me on Silica. My @ is Dushant, and yeah. So let's move ahead with the scope of what we're going to be talking about. So in any business, any product that you see, if it's not hardware, it's going to be software in tech, at least. That much is obvious, right? And in some cases, the software itself is a selling point. Like if you think about Microsoft Windows is a pure software product. People buy it because it's very inconvenient to write your own operating system to run, right? So yeah, and in other cases, the selling point is some kind of algorithm or data wrapped in a layer of software. Like if you think about Google, people don't use Google because it's hard to write like a simple search web page. People use Google because they have a very efficient proprietary search algorithm that nobody else has. So their algorithm is their product, but to make that product reach other users, they have to wrap it around a layer of a software so that users can interact with it. So like irrespective of what your business idea is, if you want your users to use your product, you need to be able to write some software around it so that they can interact with it. So like even if you are say very good at machine learning or blockchain or networks or any other field, if you want to make something usable, you need to give them software. They're not going to be running your Python programs from the command line after all. Like they'll need an interface, and even then they still might not like it. That's what you did in your CP labs, right? But the kind of stuff you want to do is this. You've probably used Discord at some point in the online sim, right? For obvious reasons. So how do you code an entire app like Discord? Like, it's so complex. I mean, look at it. There's pretty UI, there's voice and text chat, there's all kinds of buttons and filters, there's the ability to send files, there's messaging, there's so much business logic going around. And forget the business logic. Even if you just look at the user interface of Discord, if I asked you to recreate this exact screenshot in Microsoft Paint, like just draw it as it is, it's still going to take you a lot of hours to do this. But the developers of Discord, they didn't draw this in MS Paint. Said they made like the whole thing with code. So with just code, they specify that there needs to be a text box here that needs to look like this. There needs to be 4 buttons here. There needs to be a list of friends here, and so on and so forth. So this is the kind of stuff that we're looking to build, not basic command line programs in C. But how do we do that? How do we get from A to B? How do we get from coding noob command line programs to apps like Discord? Now, luckily, this isn't like, it's not a long way. It's not like you have to master those command line programs before you move on to stuff like this. It's, you kind of get there instantly. And you get there by using frameworks and APIs. Now, frameworks implement all the low-level stuff that's needed to make your software work so that you can focus on your app's core logic. Like, you can think of frameworks like someone saw how hard it is to go from command line programs to proper apps. And then they wrote a bunch of code that everybody else can use now to, like, make such apps. That's all that a framework is. It's just a bunch of code in a certain language. So technically, you can build stuff without using a framework, but then you'd be redoing a lot of work that the framework already takes care of. So it's like reinventing the wheel. You don't want to do that. So to write software quickly and safely, you usually use frameworks. The other thing, APIs are something that they allow different pieces of software to communicate. Now, these different software processes, they can be running on different machines, they can be written in different languages, but they can still communicate and interact with each other. And that's how we can make software scale, like write different pieces of software in different specialized languages so that it works. Now, unfortunately, there's a lot of different kinds of APIs. There's web APIs, there are just simple functional APIs and so on, but we don't have enough time to get into the definition of APIs in any more detail. Instead, eventually, we'll discuss a specific kind of API, the web API, in brief. But other than that, I recommend that you read about these later. Now on to frameworks. So let's not spend more time on the definition of framework. I've already listed out a lot of definitions till now. So let's talk about what some concrete types of frameworks. Right. So primarily you need two kinds of frameworks. You need client-side frameworks, you need server-side frameworks. Now, software using client-side frameworks run on devices that the user owns. Right, like take the example of Discord. The Discord app's code runs entirely on your device. The code is responsible for rendering that pretty user interface on your screen, filtering your voice, detecting when you are speaking, when you're not, and so on. That code is written using a client-side framework. And software using, on the other hand, server-side frameworks, they run on remote servers that you or your company owns. So extending the Discord example, when you send someone a message on Discord, what you're doing is you're actually sending a message to a server, and the server software will then forward this message to the device of the user whom you want to send it to. Right, so such software is written using server-side frameworks. Now, I'm going to show you a demo of both of these frameworks pretty soon, but before we go over that, we need to discuss one more definition, one more concept. That is HTTP. Now, pretty much any app that you've ever used is probably using HTTP. And you might have an idea of what it is. It stands for, I think, Hypertext Transfer Protocol or something. Clients and servers use it to communicate between each other, but we don't care about the definition. We care about how it actually works. So here's an example. Like, let's say you go to Instagram.com, right, in your web browser, and your browser, like what's actually happening behind the scenes is your browser creates a GET request. A GET request is a type of HTTP request, and this request is sent to Instagram server, and the server then returns the source code for a web page in response, and your browser takes that source code and displays it. So it feels like you just entered a URL and a web page appeared, but behind the scenes, that's what's happening. And HTTP requests can contain data in all kinds of formats. You can send simple text, you can send JSON, you can send media files, whatever you want. And the job of the server is to read this data, do some processing with it, and return some response. Now, that's a lot of words. It's like, I don't expect you to get this right away. So let me help you visualize this. Can you see, draw out this diagram Can somebody confirm?
Yes.
Yes.
Yeah. So let's say this is you, right? And this is Instagram server. Now you want to see the home page of Instagram. So what's going to happen is your browser is going to create an HTTP request, which looks like this. So it's a GET request. The type of the request is GET. The URL is /home, and you're sending it to Instagram.com. Now this request goes to Instagram server, right? The server can read this request. The server realizes that the request is to /home. It can access the URL that the request came on. Then once it realizes this, the server will fetch the web page from, like, it will construct the web page however it wants. The web page will be something like this. Then there's going to be some HTML, some CSS, and the server is going to send this as a response back to your client. And now the web browser that you're using, it's going to take this HTML and it's going to display it. And that's how you see Instagram's web page. Now we can extend this example. Let's say you wanted to create a new post, right? Like you also send data to servers. So what happens then? So when you create a new post, your web browser is going to construct a request like this. So it's going to be a post request. This is another kind of request. Now, post here doesn't mean Instagram post. Post here stands for you posting some data, just like letters to people. So this is a post request to /new post. This is another URL endpoint. And again, it's to Instagram.com, but this time it's not just a request. You're also sending some data. You have to send the image that you want to upload, and you have to send the caption that you want to go with your image. Like, that's the two things that you specify when you upload on Instagram, right? So this request is now going to go to Instagram server. It's going to read this request. It's going to get the image and caption. It's going to create a new post. It's going to assign it a unique ID. Let's say that unique ID is 23. This is random. And it takes this post and saves it inside a database. So now this post is here. And once it's done, once the server knows that, yes, the post is finally in the database, it returns a response because it needs to tell you that, yes, your post was uploaded successfully. So the response comes back. The response says 201 OK. 201 is just a status code. So it says 201 OK. Your client now knows that, yes, my post was updated, and you can discard this response, and the server can now discard this request because the work has been done. So that's how resource creation works. Now let's say once you created the post, now you want to see your post, right? You want to display it on a web page. So what do? You usually go to an endpoint like this, like Instagram.com/some post / the ID of the post, right? So in this case, the ID is 23. And then the web page that shows up displays the post that you want to see. Now, in our case, if you want to do this, all we need to do is send a GET request to /post/23. This GET request goes to the server. The server can read this. The server knows that the user is requesting post number 23 because it has access to the URL. It asks the database to give it post number 23. It gets post number 23, and it just sends a response back to the client. And this response already has the post embedded in it. So your web browser will then render this HTML, and you'll see a web page in front of you. So this is how HTTP works. This is the server client architecture that almost all modern apps use. Like, there are other ways to communicate, but this is, I think, by far the most popular. Now, does anybody have any questions about this? I'll wait for like 10 seconds.
The returning file is also HTTP.
It's files are not HTTP. Like HTTP is the protocol. Like this whole process, sending the request, getting back a response, this process has to happen by a set of rules, right? Like how are you going to send the file? What is a request going to start with? How does it end? What are the request headers and stuff like that? HTTP defines those set of rules that both the server and the client have to follow to communicate with each other. So yeah, you can say that the response that it gets back, it's called an HTTP response. Yes, this is called an HTTP request, and this is called an HTTP response.
Okay, so the HTTP is essentially the entire cycle.
HTTP is the set of rules that governs the entire cycle.
And the file is HTML in this case.
The file is, yeah, you can say that. The file is actually just text, but the browser interprets it as HTML. Any file is technically just text, right? It's just zeros and ones. So yeah, you can say it.
Okay, thank you.
Does anyone else have any other questions? Cool, let's move on then. So this was the HTTP request response cycle, right? And now we can formalize this whole process using what we call a server-side framework. Can you see the slides?
Yes.
Cool. So did you notice like a pattern in all the requests we sent to Instagram back there? Like if you think about it, in all those examples, the server's job was to run a particular function whenever a certain request comes on a certain URL endpoint. So like all we need to specify to the server is that when a request comes on this endpoint, you need to run this function. Like I'll show you, wait. So in the new post, when you wanted to create a new post, you probably had a function like this on the server. So the programmer specifies that when this URL endpoint is hit /new post, you call this function, and this function should have access to the request that is sent. So what this function will now do is it will get the image from the request, it will get the caption from the request, it's going to create a new post object using the image and the caption, and then it's going to save it to the database. Can you read this? Is this visible? Is this text legible?
Yes, yes.
I can zoom this. No, I can't. Yeah, anyway, I hope this is legible. So yeah, this is what's happening. There's a URL, there's a function registered at this URL, which will always run for every request that comes at this URL endpoint. Right. So it can get the image and caption, save the post to database, and return the post in response. This is what we did when we wanted to create a new post. Now, when we wanted to view a post, we had a function like this. The programmer specified that at any URL that looks like this, basically /post/anything. So this is a variable in curly braces. Whenever we get a request at a URL that looks like this, we want to run this function getPost, which has access to the request and has access to that parameter in the URL, that variable in the URL. So in this case, when we called /post/23, we actually ended up calling getPost request, 23 on the server. Now this function will just get the post from the database and it will return the post. So this is what we need to do with a backend framework. This is the kind of functionality that we need from a backend framework. So that's what backend frameworks do. They let you specify what piece of code to run when someone navigates to a certain URL. And this said piece of code has access to the URL that it's running on, like and the request data that was sent to it. Like again, like I just mentioned, when we wanted to upload a new post, the code has access to the media and the caption we sent in a request. When we wanted to view a post, the code had access to the post ID that was embedded in the URL. So that's what a backend framework allows us to do. And in this said piece of code, we specify what information we want to return to the client who sent the request in the first place. So in the case of Instagram, we wanted to reply with the actual post that was requested. And then this information can be rendered by the client in whatever pretty way that it wants. And if you think about it, this is all the functionality you need for writing server-side software. This is literally it, nothing else. So like you can recreate, let's say, take Facebook. You can recreate the entire Facebook website using just this much functionality. Like try thinking about it, try doing that sometime. It's going to be fun. So yeah, now this was just a visualization of how HTTP works. I'm now going to show you, like, I'm going to introduce you to an actual server-side framework that's very popular among software engineers. It's like heavily used, and it's very, it's famous, and that is Express.js. Now at BITS, if you've heard your batchmates saying that they're learning Node.js, they probably meant that they're learning Express.js, because so it's a simple server-side framework written in JavaScript, and it's based on Node.js. If you don't know what Node is, definitely go read about it after this talk. We can't discuss it here, but it's interesting. You should read about it. So if you want to build something using Express, you need to use JavaScript, because Express is written in JavaScript. And like I mentioned multiple times by now, the job is simple. You just have to specify what code to run on what URL when a request comes there. And you'll actually have a better idea once I show you how this actually works. So right here, I have some code. Can you read this?
Yes.
Yes.
Is this big enough? It is? Okay. So ignore this code. This is all boilerplate that you'll always end up copying and pasting. I also copied and pasted this. Pay attention to what I'm going to do. Now, I want to make something like Instagram. So basically what I want is when somebody sends a request to /post/some ID, let's say ID1, I should display that post on the web page. That's my motive here. So what I'm going to do is I'm going to define a new endpoint. So I want /post/some ID. This is how I specify it in Express. When it's a variable, you just append, like you just insert a colon in front of it. And now I'm gonna register the function that I want to run whenever somebody sends a request to this route. Right, this function will get two variables passed to it. The first one is request. This variable is going to contain all the information about the request. Like previously, when I showed you how Instagram must be getting the image and the caption from the request data. So we're going to get our images and captions using this. So this is where all the data is. And the response variable is what will be returned to the user finally. So we can modify this variable, and when the function exits, the user will get an appropriate response. Now you'll understand this better when I do this. So the first thing we want to do is get this ID from the URL. This is simple. You just need to do request.params.id. And now you have the ID. The next thing you want to do is like prepare a response that you want to send. So let's say we'll send something like this. It will be HTML. There's no autocomplete because I'm not doing this in an HTML file. And the first thing we want to do is we want to show some kind of image. Where will the image come from? I'll tell you later. And the next thing I want to do is show some kind of caption. Now, where do the images and captions come from? If you see, I have this some data here called posts. If you have any Python or JavaScript experience, you'll know what this is. And if you don't, just think of this like a C struct where I have certain data against certain fields. Right, so I can get the post like this. So the name is posts. I have the ID. So I can fetch a corresponding post by the given ID. So if the ID passed is I1, I'll get this object in the post. If the ID passed is I2, I'll get this object in the post. So I have this. Now this post has two properties. It has a caption and it has a URL. So in the SRC, I'll here put a caption and no, wait, this should be the URL and this should be the caption. Right? And now all we need to do, we have a response. We just need to send it back. Now let's try running this. We can run this pretty easily. We just need to call the node process. Don't worry about how I'm running this actually. You can get all that in some online course or something. Now the URL pattern is /post/ID, right? So I can go to a new tab and wait, what was the port number? The port number was 9090. So 9090/post/ let's use I2. And I hit this and I get this. So this is the image at that URL and this is the caption, as you can see. This was the caption. This is the image. When I hit I2, my server will get the ID. It will get the corresponding post and it will create a response for the client. It will send it and my web browser will automatically render that response. Now I can dynamically access another post. Like if I post here /I1, I get a different thing. I get the first one, which is this. This is an airplane. Now I can change this caption, like maybe which is flying. I need to rerun the server. And if I reload, the caption changes. Now this is very rudimentary. This is you're not going to be required to do this in any kind of internship or startup or whatever project you're going to be working on, right? But you have to get the essence of what I'm trying to convey here. This function basically took a variable from a URL. It fetched the data from somewhere using this. It generated a response like this, and it sent that response back to the client, and the client then rendered it. Now, of course, I could have sent like, I can send actual data inside the request instead of sending it in the URL, but I leave that to you. Like, try that on your own. It's not hard. Also, let me see if I can show you this. So this is my network tab, right? When I refresh, the network tab registers a request. Can you guys see this?
Now it's visible.
It's visible, right? So when I reload, you can see what's happening. Like if you open the Chrome DevTools, it shows that I sent a network request to this endpoint, post/I1. It shows that the request method was get. It shows the status code, shows where I sent it. And then this was the request. If you look at the response, this is the response that my browser actually got. It wasn't some automatically generated web page. It was just HTML. This is what my browser got. And my browser then took this HTML and automatically rendered it. That is the browser's job. That's what browsers are for. So yeah, this is how it works. Does anybody have any questions about this? Anything you want me to explain again? Anything you didn't get? I'll wait for 10 more seconds. Cool, nice. So this was Express.js. Now, I just demoed it. So the next thing that we want to look at is client-side frameworks. So what you just saw, the server specifying to the client what to render. Like in this example, I wrote the entire HTML and sent it to the client, and the client then rendered it. So this is called like it's called server. Wait. Why can't I? Yeah. So this is called server-based rendering. Now, such a method of rendering it's suited for websites, but if you're looking for like a smoother experience, you need to use some kind of client-side framework, because if you're going to make a web app, you don't want it to feel like the ERP portal, which like refreshes every time you click a button. That's not what you want. You don't want to load a new page every time somebody clicks a button. You need your user interface to be smooth and like, you want it to be fluid. So the idea is to have the client-side code and everything already downloaded on the user's device, and the server then only sends variable data. Like in this case, what would happen is like this HTML that you're seeing, this would already be at the client. So I won't need to send the entire thing. I'll only send the post URL and the post caption, and then the client will insert this in the HTML and render it. So that leads to a much more smoother way of rendering UIs. And if you think about it, this is how Android and iOS apps work on your phone. Like the code to render stuff is already there. A mobile app already knows how it's going to render data on a screen. The only thing that it needs a server for is to get the actual data that it's supposed to render, not the surrounding logic. So that's what a client-side framework is for. Now I'm going to show you an example of a real client-side framework called React. But before that, we need to just briefly touch upon what web APIs are, just for the sake of completeness. Now, web APIs are used to, like, when you write client-side code separately and server-side code separately, when you don't use server-based rendering, you want your client to be able to talk to the server to exchange data, and this is done with web APIs. So data is sent and received in a format that both the client and server understands. We already discussed this, and one of the most popular formats of sending and receiving data is JSON. Again, read about JSON. It's going to be very handy if you're ever going to write software. Now the server can encode the data it wants and send it in this format, and the client will have some kind of functionality to decode it, and they can communicate this way. So yeah, that's how web APIs work. So basically, like I said, the client would already have this code, and then the server can take the URL and the caption, encode it in JSON, and return it. And actually, I can show you how it looks when it's encoded in JSON. So it's like this. We have the caption and we have the URL. Let's restart. And now if you refresh, you'll get this. So this is JSON data. I mean, it doesn't look very remarkable, but this format is such that a client device can easily read this, and then in the client, you can do something like this, data dot caption directly. you won't need to write an entire function just to parse your data recursively. So it's easy that way. So that's what APIs are for. If you want, I can, like at the very end of this talk, after Kavya is done, I can quickly code an API and like, using Express.js and it interacts with clients. You can stay back if you want. So yeah, now the next thing that we're going to talk about is React. Now React is an actual client-side framework. It's probably one, I think it's the most famous right now. It's the most used. If it's not the most used, it's definitely in the top 2 most used frameworks. So like if you're looking to get started with any kind of front-end development, client-side development, I'd say start with React. So React is also written in JavaScript, which again means that if you want to use React, you need to code in JavaScript. There's no other way. You could code in TypeScript. And we use React to make progressive web apps. So basically, a progressive web app, PWA, it's a website that behaves like an app. Now, I'll tell you something interesting. If you want to see an example of a PWA, you go to flipkart.com on your smartphone and pin that site on your home screen, and then try opening it from your home screen and see how it behaves. You'll notice it's exactly like an app. It doesn't even show you that browser URL bar anymore. It's just like you installed Flipkart on your phone. So that's what PWAs are for. Now the code you write using React, it's run by a web browser. You can't just execute it like you execute a normal C program. Any client-side code for a web app is run by the web browser, not directly by the OS. And it uses a reactive programming approach. So you define a program state and the UI updates every time the state changes. Now, if you've never tried this, you probably didn't get what I mean. So I'll do another very short demo of React. Can you see the code?
Yes.
Yeah. So this is a very basic example of React. I'll first wait. Let's just write hello there. Right. And let's run this. It's going to take a while to load. And it's there. So this is our React app right now. That's all there is to it. There's just a hello there. Now, what did I mean by reactive programming? Basically, let's say I want an app such that there is a button, right? Let me just code it. So let's also add some BRs because we are classy people. Yeah, so we have this, right? And what we want is whenever I click this increment button, this should increment and the page should not reload. Like I could do this easily with a server. Every time it increments, I would send a request to a server. It would update the variable and send a new web page every time. But we don't want that. We want the experience to be smooth. So every time I click it, without any reload, without any network requests, this should increment. So what I can do is I can define some state. Wait, let me just close this. Yeah. So I can define state like this. Don't worry about the exact code that I'm writing. Just follow the approach. Right, so I define state, which is called count. I'm going to use this count here instead of a hard-coded value. Right, and the initial value of this count is 0. Let's refresh. Now it's still 0, clicking increment still doesn't do anything. Now what I want is, let's say I want an app such that there is a button, right? I'm going to use this count here instead of a hard-coded value. Right, and the initial value of this count is 0. It's still 0, clicking increment still doesn't do anything. Now what I want is, let's say I want an app such that there is a button, right? I'm going to use this count here instead of a hard-coded value. Now what I want is to tell React that whenever this button is clicked, I want to run a function. So I can do it like this. I can register an on-click handler on the button. So I'm telling it that whenever somebody clicks a button, run this function. And the function that we're going to run is setCount. SetCount will just update the value of this variable. That's its job. It's not rocket science. And what do we want to set count to? We want to increment count. So we'll say count +1. This is what we want. And now when I press increment, it increments. And if you notice, there's no network request here. This is entirely happening at the client side. The server is not involved. And you can guess how this might be useful. Like this is again a very rudimentary example. Nobody's going to ask you to do this, like incrementing something with a button. What you'll instead be doing is like you'll have a nav bar here. In a typical website, when you click on a nav bar entry, what happens is a new page loads. But in a React app, what you can do is without loading a new page, keep the nav bar there and just load the rest of the contents of the new navigation section. Again, I can't explain this without a visual example, but I don't have the time to code a visual example here. So if you want to know how something like that can be done, you can text me on Silica and I'll show you a project that we've been working on at ACM where we do something like that. So yeah, that was React. It was a light demo, but that's how it usually goes. Now, again, if you want to get into React, this is it's a very good time. React is being heavily adopted by a lot of companies. You can do any standard course on Udemy and get started with it. Like, I really recommend this. Now, what about desktop apps? Because we have been talking about these websites, web servers, web apps all this while, but for some reason, when you say software development, the first thing that comes to mind is an actual desktop app, not a website. But if you think about it, the difference between a web app and a desktop app is just that a desktop app doesn't run in a browser. That's it. Both of them have the same capabilities, they can do the same things, and they are written the same way. Now, web client frameworks like React Js, they use functions that are exposed by the web browser to draw stuff like text and shapes on your screen. Like at the low level, that's what's happening. React is talking to your browser. Like in a similar way, desktop frameworks like, let's say, Apple's Swift UI framework, they use functions exposed by the operating system to draw text and shapes directly on your screen instead of in a browser window. So the bottom line is anyway, you don't have to write code that explicitly handles the position of every pixel. You'll never need to do that. There's always going to be a framework that talks to the underlying display, which lets you handle things at a high level. So there'll always be one. And for the record, if you want to write desktop apps and all you know is web development, you should check out Electron Js. Electron, what it does is, you know how React runs in the browser, right? What Electron will do is it will ship the entire browser with your code. So every Electron app comes with like a Chrome instance, and you can write React code and run it entirely in a browser. Technically, what's happening when a user runs your app is he's technically starting a web browser and then running stuff on it, but it feels like it's a proper desktop app. Now, Slack is based on Electron. Slack is built entirely on Electron. Postman is built on Electron. A lot of desktop apps, cross-platform desktop apps are built on Electron, because with Electron, you don't need to use any OS-specific functions like Apple's Swift UI. So a single team can develop the desktop app for all the platforms, Windows, Linux, Mac OS. Anything that can run a web browser can run an Electron app. So that's also pretty exciting. You should check Electron out too. So yeah, with this, we're done with software engineering. If you have any questions, you can ask them at the end of this talk, or you can ping me on Silica. for now, we're going to move on, and Kavya is going to show you how prototyping works. So over to you, Kavya. Oh, by the way, before we end this, does anybody have any questions about the last few slides?
Yeah, can you explain the electron part again?
Okay, so let's say you go to Postman, right? Can you see my screen?
Yes.
Okay, so this is Postman Atomis. This is their web app, right? This is running inside a browser. I can't just take it outside a browser and run it there, correct?
Yes.
What Electron does is it will take your code, it will save it statically, and when you want to ship your app, when you want to give a user your app, it bundles your code with a browser instance. When an Electron instance runs, it looks like this. There's no URL bar or anything. There's just the bare minimum browser API required along with your code. So every Electron app is basically a web browser running some JavaScript. Did you get it?
Not much, but yeah, I get this.
You know what? You should go to this website, electronjs.org. I'll post it there. You should go there. They have very good documentation. They'll get you started. And oh, by the way, Visual Studio Code and WhatsApp are also built on Electron, and so is Figma. So yeah, check it out.
Thank you.
Yeah, I can. Anybody else, if you have any questions, you can also write in the chat box now. I'll stop presenting so that Kavya can present.
Just present my screen.
Go ahead. If you have questions, then ask me at the end of this talk. Now, Kavya can go on with prototyping.
Is this visible?
Yes,
Are the slides visible?
yes, it's visible.
So hello everyone. Today I'll be talking about prototyping. Now, before starting, I'd like to introduce myself. So I started programming over a year ago, and currently I'm in my second year. I have worked at a few startups, and currently I'm working at a BITS-ACM startup. I'm a front-end developer, and I have also worked with frameworks like React.js and Vue.js. And apart from this, I'm also passionate about UI and UX design. You can also reach out to me for anything on Silica at kavyashree1903, and you can also follow me on GitHub at kavyashree1903. Now, what exactly is prototyping? So picture this. You have an idea that you believe is ready to break the market. And you and your team have been putting countless engineering hours in it. So only to realize that your idea is actually terrible. So you don't want this to happen to you, right? So this is where the prototyping would come in. It would provide to you, the entrepreneur, a set of tools that and approaches for exploring and validating your ideas before you spend too many resources on them, so that the resources do not go in waste. Formally speaking, it is a simple model of a proposed solution used to test and validate ideas, designs, other aspects quickly. So it is typically done between the formalization and the evaluation of an idea. So some tools that you can use to build your prototypes are Figma, Adobe InDesign, Sketch, and Protopy. Now here I'll be talking about the scope of prototyping. So when hiring new devs for a team, it is an added advantage for the devs with previous design experience. So you must be thinking why. This is because it has been found that these members have much greater attention to design details when developing UIs. An added an added advantage would be that instead of back and forth conversations and asking for images or colors of fonts from your designer. You can find the information all out for yourself. You don't have to rely on someone to get back to you and give you these things. And honestly, this process becomes cumbersome and irritating. So in order to escape that, also as a developer, it's important to have basic knowledge of UI and UX design. As Now, as mentioned earlier, an MVP is a version product with just enough features to be usable by early customers who can then provide feedback for the future. Now, think of an app like Swiggy. An MVP for such an app would be just a small two-page app which has order delivering tabs and where you can deliver ordering tabs where you can order your food from. So similarly, an MVP is an integral part of your product management lifecycle, and it gives insight to your product and also allows you to incorporate major changes early before the ball is dropped. It is not just important for the developers, but also the marketing and the business teams, since they can create a buzz for your next big thing. Now, for an app like Instagram, an MVP could be an app with just only one feature that is uploading and sharing photos. It should be thus no surprise that careers in prototyping have been steadily growing and expanding with new technologies popping up every day. Now, I'll be talking about the advantages of prototyping. So, as an example, just a decade ago, taxi services didn't provide great user experience, right? You had to call a company like Meru to request a cab, and then rides were sometimes limited or the process was too cumbersome. And then Uber came along and changed the game. So, with Uber, ordering a ride now takes less than a minute and about 4 to 5 taps. So, all this happened because Uber looked at the problem from users' perspective and created a better experience to solve it. Hence, prototyping enables you to create something that would impact so many lives. And prototyping allows you to define the scope of the project and also gives you a feel of what the actual product will look like after the production. It allows you to focus on the user experience as well as it ensures better word of mouth among your consumers. Now, these are the few things that you need to keep in mind while you prototype your product. So first is to determine the goals you are trying to achieve with your prototype. Now, it is very important for any developer to have a clear vision of what they want to build that makes the end user's life easier. So nothing comes out of half-baked conversations, right? It is the small nitty-gritty that matters more in a project. So now think of an app like Swiggy again. The main goal of an app like this is to make food ordering easier. Everything that you build should be you should be keeping this goal in mind. Now define the scope of the prototype. So determine how much time needs to be built to meet your goals and what tools would you use. You can also use some traditional methods like drawing on pen and paper, or you can use tools like Figma, XD, etc. But for a big project, the latter, you should always go for the latter. Plan your design. So think through the overall structure, layout, navigation, components, content, graphics, and any other elements based on your goals. So again, here main goal is to give the users the best experience. So this can be done by making pretty interfaces, reduces the number of clicks to get something done, etc. Now, building the prototype. So this is about reviewing and refining the prototype along the way to ensure it's complete enough to meet the goals. So there shouldn't be any half-done features in a prototype. The prototype should serve the basic purpose. Coming to use the prototype with your intended audiences to accomplish the prototyping goals. Now, here it means this like having reviews, walkthrough, usability tests, stakeholder demonstrations, communicating with the team, etc. Then it's about collecting and analyzing feedback. So designing a prototype is an iterative process. You can never get anything right in the first go. So you have to identify the key findings, you have to identify the recommendations, you have to identify the next steps. You might have to redraw your prototypes also based on the feedback received by the users. And the last point would be to consider additional prototyping activities as needed. So this may include building a more elaborate prototype, developing competing prototypes to explore design options, and to shifting from simple prototyping tools, like I mentioned before, paper and pencil, to more sophisticated tools like Figma, Protopie, etc. Now I'll be showing you a quick demo on Figma to how to prototype a product. If you have something in your mind, you can always bring it out on the software rather than just keep like, so that it's become easier for you to explain your idea to everyone. And this is especially useful when it's the case of a startup. You can easily pitch in your idea using a prototype without having to code and wasting resources. Is anyone having any doubts? You can ask me. Is my screen visible?
Yep, we can see Figma.
Okay. So Figma is basically a free online UI tool where you can create, collaborate, and prototype your products. So my personal favorite is Figma out of all the UI tools because Figma, first of all, is free, and second, you can collaborate it over it like Google Docs. So as I open the software, you can see a nav bar having some tools and frames. So frames are basically the screens that you would be seeing in your app. So this could be the first screen of your app, and this could be the second screen of your app. On the sidebar, there are layers and the positioning of images and components. The right sidebar has three options. So first of all, if you click on some option like this, you will get the design specifications. You can increase the size, you can give it alignment and different things you can give it. Then the prototype option means to adjust the prototyping settings. This I'll show you while I'm done with the design. And in the end, there would be inspect. So as a front-end developer, I can tell you like this is the most convenient feature of Figma. You can just easily use CSS because CSS is really cumbersome to write, and also it's very difficult to adjust things just by looking at them. So CSS is, you can just get CSS through it. You can also get code for native iOS and Android apps if you want to style your Android or iOS app. And apart from this, you can also get the HTML code if you use the plugin. I currently do not have the plugin installed, but if you can install it, you can directly get the HTML code out of the frame. So now what I have in mind today is a shopping app where there would be a product and its description, and description upon clicking the image. So there would be a product. If I click on the product, I'll get the description of the product. So the color theme that I have chosen is from a color palette generator, and now I'll be starting with the design. So when you look at some app, any app, so you break it into components. Breaking it into components like navbar, sidebar, there are components like buttons. So we will be doing the same. I just designed a navbar. By the way, these icons and assets, I've just kept them here. You can download your assets in PNG or SVG format, and then you can drag and drop there. Just for your ease and to save the time, I have just put them here. Now I'll just make a search bar. So in Figma, you can see that there are red lines and stuff. So it becomes very easy to make your things and align your things. I'll just give it some color, and after that, I'll just give it some stroke effect. I'll give it some drop shadow. And again, I'll use the icon for search. And now I'll put a placeholder text in it. So now this is adjusted. Now I'll just put in a product image. So for the product image, I'll just go with something very simple. I'll just use a rectangle. By the way, you can also get free images from Unsplash or sites like Freepik, so that you can get free stock images from there. I'll adjust my image according to the box. Now I'll just I think I could use the orange one rather than this. So I'll change the color. You can use hex code generator. You can use poolers to get different color palettes generated. So you can use any theme from that. And I'll just put so this I had made beforehand. I had put the text, the description, and I added an icon to favorite something. Now for the next product, I can just copy the whole thing. I can change it according to the different product. You can change the background color here. You can change the image also. And I can change the name of the image maybe. So now my main idea here is if I click on this flash t-shirt thing, the product description page of this opens up. So the icons that I'm using are from Icons 8. You can also use flat icons or Material UI plugin for Figma to gather these icons. Now I can just put in some placeholder text for this description. You can, if you are a developer, you don't need to have provide the content on the site. That could be taken care by the content team if you are working at a startup or something. So you can use a placeholder generator like a lorem generator to fill in your places. I'll just use some few lines to put here. Now after that, I'll just put the size tags that I've made before. These size tags are basically simple squares to whom I have given the shading and stuff exactly which I have given over here. The similar thing I have done to them. Now I'll just put in the pricing and the button. Here you can also put a carousel icon so that if you like whenever you open Amazon or something, you see that you can see the image in top view, right view, and different views. So in order to do that, I can put a carousel image. Now I'll start with the prototyping. Now here I can just specify the device which I want to use. Here I'm using an iPhone 10. Now after that I'll start with the prototyping part. So if someone clicks on this image, he should be directed to this page, right? And if someone even clicks on the product description, so he should be directed to this page. Similarly, if someone clicks on this back button, if someone clicks on the just give me a minute. I'll just add it here. Okay. So now I'm done with my prototyping. I'll just show you how does it look once I start it. I'll present another tab. I think there's some problem with the image. Never mind, I'll show you how is it working. So if I click on the picture of the image, I am directed to the next page. And in the similar way, if I click on the back button, I can come back to this page again. If I click on the product title also, I come to the next page, and then I can click back to go back to the page. Now, just the last few things. So after the Figma demo, you also refer to some resources if you are interested in a UI UX design, or if you feel like making some basic prototypes for your app. You can follow these Instagram pages. You can use these sites to find inspiration, and you can use your assets like the images and graphics from these all websites and plugins. So thank you so much. This was it for today's prototyping talk.